Now we are going to discuss about Nyquist rate and Nyquist interval. So the Nyquist rate or the frequency is the minimum rate at which a finite bandwidth signal needs to be sampled to retain all of the information. When the Nyquist rate or the frequency is equal to 2 FM, twice of the maximum frequency of the message signals. So that is the Nyquist rate. When the sampling rate is equal to 2 FM means the original signal, the message signal can be recovered. If the sampling rate is more than 2 FM means we can recover the message signal. If the sampling rate is less than 2 FM means we cannot recover the message signals from the sampled signals. So the minimum sampling rate should be equal to twice of the maximum frequency of the message signal. So that is the Nyquist rate. So is the minimum rate at which the finite bandwidth signal needs to be sampled to retain all of the information. So the Nyquist rate is called the minimum sampling rate. It's given by Fs equal to 2 into Fm. Next, Nyquist interval. So the Nyquist interval means maximum sampling interval is called Nyquist interval. Is given by Ts equal to 1 divided by 2 into Fm seconds. So next, this is the frequency values for the different sampling, oversampling, Nyquist rate and undersampling. For oversampling, the omega s, this is the angular frequency of the sampled signal, and omega m is the angular frequency of the message signal. Under omega s, when the sampled signal 2 pi fs greater than 2 into 2 pi fm. So omega m value 2 pi fm. So fs greater than 2 fm. For undersampling, omega s, that is angular angular frequency, is less than 2 omega m. So the sampling frequency is less than 2 fm. So under oversampling condition, the sampling frequency is greater than 2 fm. So we can recover the message signals from the sampled signal. And here under sampling condition, the sampling frequency is less than 2 fm. Okay, so now this condition we cannot recover the message signal from the sampled signal. For Nyquist rate, omega is equal to 2 into omega m. So Fs equal to 2 Fm. So for recovering the signals or the message signals from the sampled signals, the minimum frequency of the sampling frequency should be equal to 2 into Fm. If the frequency equal to 2 into Fm means the signals, the message signals can be recovered easily. So here Ts is the sampling interval 1 by f of s. So Ts equal to 1 by 2 pi 2 Fm. Okay, so this is the sampling interval. So here under oversampling condition, this is a shifted spectrum signal. Now here in between the, here we have the the signal does not touching. Okay, so this is the oversampling condition. Under this condition, the message signal can be recovered. So this is the under sampling condition. Now the shifted spectrum signals are overlapping. So for this condition also, the message signals cannot be recovered. So this is the Nyquist rate. So here the signals. So the spectrum of shifted signals was touching. So this is the minimum frequency of the sampling frequency. We can recover the message signal. So this is the Nyquist rate. So for oversampling and a Nyquist rate condition only, the message signals can be recovered. For undersampling condition, the message signal cannot be recovered, because in undersampling condition, the sampling frequency is less than twice of the maximum frequency of the message signal. So next, to find the Nyquist rate and Nyquist interval for the following signal. Here m of t equal to cos 100 pi t plus 2 sin 200 pi t. Here m of t equal to, so m of t means is nothing but the message signal, x1 of t plus x2 of t. So this is signal 1, x1 of t, and it is x2 of t. So the x1 of t equal to cos 100 pi t. So we can take omega 1 equal to 100 pi. And x2 of t equal to 2 sin 200 pi t. So next, omega 2 equal to 200 pi. So on considering these two signal, the highest angular frequency is 200 pi. So we are taking 2 pi fm equal to 200 pi. So from this we can calculate fm. So fm is the highest frequency of the message signals, 100 Hz. So next, Nyquist rate. F is equal to 2 into fm. So 2 into 100, so 200 Hz. Again Nyquist interval formula, T is equal to 1 by 2 fm. So you will get 5 millisecond. Okay, so this is the procedure. This is the concept of Nyquist rate and Nyquist interval. Okay, thank you.